Hey, this is Mr. Warden. This is PreAlgebra Do Now 25.3 video key. And we're going to start off by comparing our sun to the very poetically named R136C star. And I'm sure that someday someone will probably come up with a better name for it, and perhaps someone in some other part of the universe already has one. Though it would probably be very dangerous to be anywhere near it because it is so ridiculously large. In fact, it has a mass of 3.023 times 10 to the 32nd kilogram. It's one of, if not the largest star that has been identified by astronomers. It has that mass, 3.023 times 10 to the 32nd kilograms, while our sun has a mass of 1.989 times 10 to the 30th kilograms. Okay, so it's in the Large Magellanic Cloud, which is a galaxy that orbits our galaxy. It's a small galaxy known as a satellite galaxy. And it has this mass of that much, roughly 3 times 10 to the 32nd, while our sun has one of roughly 2 times 10 to the 30th. So how many times bigger than our sun is that? So here's what you got to do. We're going to be dividing 3.023 times 10 to the 32nd kilograms by, put that in parentheses, to be really clear that that's all being in the numerator, divided by everything here that's in the denominator, 1.989 times 10 to the 30th kilograms. So we'll do what we always do. We group the coefficients, 3.023 divided by 1.989, and then we'll also group the powers, okay? And so basically we multiply that quotient by this next quotient, 10 to the 32nd divided by 10 to the 30th. And of course, kilograms over kilograms cancels each other out. So let's work this out. This here is going to be about 1.5 because that's roughly 3 divided by 2. But let's get something a little more precise. And it is, in fact, about 1.5. I'm going to call that 1.52. I will round that to 1.52. So we're going to get 1.52 times 10 to the 32 minus 30. And then we can simplify that to 1.52 times 10 to the second power. So it's something in the neighborhood of 152 times larger than our sun, according to these calculations. Now, here's the Milky Way galaxy. You have to go outside of the city to really see it because there's too much light pollution blotting out the stars in the sky. It's too bright for you to see them in Framingham area or here in Somerville where I live. But our Milky Way galaxy has a mass of about 1.5 times 10 to the 12th solar masses. Okay, so one solar mass is the equivalent to the mass of our sun, which we already have that number. So based on that, what is the mass in kilograms of the Milky Way galaxy? I guarantee these are rough numbers. There's some variables that we cannot control for, but this is the rough mass. So here we go. What we're going to be doing is multiplying this time. So we got 1.5 times 10 to the 12th. That's 1.5 trillion. And I'll put that in parentheses. And that's doesn't have to be, but then that's going to be times our sun's mass, 1.989 times 10 to the 30th. Okay, and that's all going to be kilograms. Okay. We'll group the coefficients, 1.5 times 1.989. That's going to be roughly 1.5 times 2, which will be roughly 3. It'll be a little less than 3. And then over here, I'm going to say 10 to the 12th, 10 to the 30th. So let's work out what this is. It's be just a little under 3 is what I predict. And it is 2.98. I will round there. All right, so that's going to be 2.98 times 10 to the 12 plus 30, which is going to be to the 42nd kilogram. So that's the rough mass of our Milky Way galaxy. Okay, one more question to consider here for the do now. We've got this exponential expression, and there's a bunch of t's in it, and there's some numbers. So let's deal with the numbers separately from the t's, okay? I think that is a good approach for this. So I'm going to group the numbers. So I've got 2 here, which is being raised to the 3rd power. And that's being divided by 4. I could actually call 4 2 to the 2nd, since they would work that way. And that'll actually make my life a little easier. Then I've got t to the 5th to the 3rd. So I'll be multiplying 5 times 3. But that's divided by t to the 8th times t to the negative 1st. So I'm going to put it all together. We'll just move this over here. It's going to be t to the 5th. I'm just going to organize this like this first. To the 3rd, all over t to the 8th times t to the negative 1. So we're going to deal with that separately. So let's first deal with 2 to the 3rd over 2 to the 2nd. Well, that's 2 to the 3 minus 2. Okay, and that becomes just 2 to the 1st, or just 2. And over here, I've got t to the 5th to the 3rd. That's going to be t to the 5 times 3. And that's divided by t to the 8th times t to the negative 1, which is going to be t to the 8 minus 1. And I'll bring that down here. We can simplify it further. That's just going to be t to the 5 times 3 is the 15th. And that's divided by t to the 7th. And simplify that further to t to the 15 minus 7. And so we end up with 2 times t to the 8th power. And you are done. There are other ways to arrange all of this, of course. I could have dealt with the t's like this. I've got the 2. And I could have done a one-stop shopping approach, t to the 5, I'll put this in parentheses, 5 times 3 minus 8 minus negative 1. And that would work as well. I would end up with t will equal t to the 15 minus 8 minus negative 1, which becomes t to the 7th minus negative 1, and that 7 minus negative 1 is 8. And then we slap that over there together with a 2, so it ends up being, again, 2t2 to the 8th power. And you're done. I hope